Hi, in this video I'm going to go over how I use Unity's scriptable objects to develop my RPG systems. So for those unfamiliar with Unity, scriptable objects are basically instances of your classes that you can create and edit within the Unity editor. And the goal of this implementation was to make it as easy as possible to quickly create and edit all the RPG content, while keeping all the systems as modular as possible. And I'll also show later that this system makes it so there's very minimum programming that's required to make new content. So for example, all the skills in the game use scriptable objects to store their data. Here we have a basic punch skill. And the scriptable object looks like this. And this allows you to tweak every possible attribute for this skill. So for example, if I wanted to edit the damage, which is 1 to 5 right now, I would go down here to damage data. And just to make it clear, I'll make it only deal 10 damage rather than a range. And here we just have to use my rebuild console command. And we can see the tooltip has changed. It now deals 10 damage. So this project started all the way in 2014, so there's some really old code here that I don't necessarily condone. Generally everything works and I'm happy with the class design, but encapsulation is quite bad. You're going to see a lot of members that could definitely be private rather than public, as well as some silly things like bool variable names not being prefixed. But it just wouldn't be worth my time to refactor the whole code base at this point, which is one of the reasons why I decided to cancel the project. So we look at the code here. This is a melee class for the punch skill, and that's part of a larger class hierarchy here that contains everything that a skill needs. For example, updating the damage based on the character stats. So as you can see, scriptable objects also have all the advantages of object-oriented design, like inheritance and polymorphism. For example, we have this trigger skill virtual function that all skills have, where I can define what happens when we first trigger the skill for all the different types of skills. As well as this animation trigger function, which all these skill animations have. For this cast animation, the animation trigger will be here where the arms are reached out. Most of the time, this is used to spawn the skill object that actually deals the damage. So let's look at a slightly more complex skill like Fireball. And this is part of the projectile class, which comes with its own relevant attributes. For example, if we wanted to change the projectile speed, we would just have to change these values here. So I have an upper and lower bound, which gets randomized. So to make it obvious, I'll just increase both. And then we rebuild skill data. And as you can see, it's a lot faster now. Of course, we don't have to type in the console command when we edit this outside of play mode, but I'll explain later why we need that special command. So if we wanted to change the shooting angle, there's also an upper and lower bound that gets randomized. So let's just enter some bounds here. And then now there'll be some spread to the projectiles. We can also make it fire multiple projectiles using this value here. As well as add a delay between each projectile. And if we wanted to make it shoot a completely different kind of objects, we just have to edit this, which accepts any prefab. So if we wanted to change it to an ice projectile, I just have to select the objects. And now it looks like this. So all the positioning in this game is in a quantized one-dimensional grid. So we can also change the range of the skill using this value. And we can easily add knockback just by editing this number here, which is the number of grid cells. And as you can see, it got knocked back twice there because we have multiple projectiles. And that's because we have this effect shotgunning toggle on. So if we turn it off, that means that things like status effects and knockback will only apply once per cast. And anytime we edit any of this skill data, the tooltip will of course also reflect the changes. It would take too long to show every single tweakable option here, but as you can see, it's really easy to tweak any option we want in runtime or in edit mode, and we can do it all without editing any code. It's also very easy to create new skills. All we have to do is go create skills, and let's say we want another projectile skill. And we'll call this skill test projectile. And we need a name, let's say test, and an icon. We'll pick a random one like this pumpkin here. Here we can search test, and we have our test skill with the pumpkin icon. And just to show that it works, let's just give it some quick values here. So let's say it does 13 damage. And we'll pick the punch animation. And just to make it interesting, let's make it shoot this black hole effect, which is a shader experiment that I've done and haven't used for the game yet. And that looks something like this. If you want to see how this works and all these other shaders, you can check out my other video. So to easily make a projectile that does damage, we can start with a template like the fireball. So I'll just duplicate that. And it's very flexible what you can use as a skill object. Basically, it just requires a collider and some sort of damage controller. In this case, it's a projectile damage controller, which is part of a class hierarchy that has everything we need to deal damage. So we remove all the fireball effects here, like this particle system and this smoke. We can come here and grab our black hole effects and copy it back into our test object here. So let's rename this to black hole objects. And finally, we can add it to our test projectile scriptable objects. So we come back to play mode. We have our test object with the pumpkin icon. And let me just increase the range so we can see it better. And I actually forgot to zero the local coordinates here, so make sure you do that. And finally, we can shoot our black hole. And aesthetically, we can turn on cascade targeting, which makes it look like this, which makes more sense for projectiles. So the projectile destroys quite abruptly, but we can also add custom behavior to objects when they're destroyed. And that does require some scripting, but that can be done easily by adding a onDestroy script on the black hole object here. Some skills have secondary effects like Frost Sphere. As you can see, it shoots secondary projectiles. And how that's done is in this skill object here, we have something called a secondary initializer, which is basically a script that has functions that are guaranteed to be called when the skill object starts. So it inherits from an abstract class where this function here is called in the damage controller if it exists. The secondary initializer is quite useful for any skills that require some more ad hoc implementations, like for example this grapple skill. So like projectiles, melee skills just spawn a skill object that's right next to the character. And we have the grapple initializer here, which inherits from the same skill secondary initializer class. And this is a nice modular way to add all the code we need for the grapple behavior without affecting any of the other skills. Another example is the character stats here, which is split into attribute and damage, just because their values are calculated slightly differently. And of course, both of these scriptable object classes inherit from the same parent class. So if we take a look at the class for the damage stat, it contains a lot of tedious functions to calculate everything we need. So accuracy, crit chance, and resistances are all stored in the damage stat, as well as all the different damage modifiers and tooltip string generators. All the stats will show up in this stat page automatically, but to make it not excessively long, I only show the ones that are modified from the default values. These stats also double as the tagging system. So every skill like Fireball, if we look at the top, it says projectile and fire. Those are both damage stats that are in this folder here. And the tags can be edited in the skill scriptable objects. So let's say we want to add a new damage type to the game. It's as easy as making a new scriptable object in this folder. So we go here, create, and character, and damage stat. And I don't know, let's just call this magma damage. So now we go back to the Fireball scriptable objects. We can add that as a tag. And now deals magma type damage. So this tagging system is very similar to something like Path of Exile, which means if we have the matching damage increase stat, it will apply to every skill with the matching tags. So just by adding that new magma scriptable object, we now have a way to create magma type damage as well as magma resistance for the character. There's lots of ways of gaining stats in this game. One of the ways is items. So items are built from affixes, which are also scriptable objects. And these are split into different affix groups, which is also a common thing in many ARPGs. And this is just a way for us to have control over item generation. So for example, we could say we want 2 affixes from the B affixes, which are resistances, and 1 affix from A, which is character resources like life and armor and stamina. So this is basically the code of what I just described. And in this function, we can tell it how many affixes from each group we want. So the reason I wanted to show the item affixes is because we can see that the stat system is easily integrated into it. And if we look at the fire resistance affix here, we can see that we just plug in the fire damage stat and the modifier type that we want. We can also specify the random ranges of each item rarity. And rarities would be your white, blue, and yellow items traditionally, but you can make it whatever color and name you want here. So generally the values up here will be lower than the ones up here. Everything is 0 here just because these are all just test stats. So if I wanted to make, say, a magma damage modifier, it's as easy as making just another affix object here. So just to be quick, we can duplicate this one and name it magma damage and change this to the one we made. And now we have the magma damage % modifier that will be randomly generated in our items. These affixes also work with the skill system where we can use it to acquire any skill in the game. So now if an item has this magma damage % affix, it will modify magma damage as well as give the corrosive bile skill. And like any RPG, we of course also have buffs and debuffs. And this interacts with all the other systems like you'd expect. So for example, Rage modifies the dodge stat and it's -1% per stack. And this is also where you can specify shader effects that are applied based on the number of stacks. So this is just yet another scriptable object that stores the Rage material for our Rage effect. So if we go back to the skill scriptable objects, we can, for example, look at sacrifice blood, and we can plug in any status effects that applies, or we can even use status effects as a skill cost. So this skill applies 3 stacks of blood right for 4 turns, and it's easily editable like everything else we've seen. So you may have noticed that all my scriptable objects are in this resource folder, and this is a very old-fashioned Unity way to load all this data in runtime. It's generally not recommended because it offers less control than something like addressables or asset bundles, but I think it fits the use case here very well. So how they're loaded in runtime is for every one of those scriptable object types, we have this database class, where essentially it's just a glorified singleton to access the dictionary that stores all of the loaded data. So this is the function we have to be very careful about, where we load all the skill data into memory. And basically this will happen anytime we request a skill instance. So this singleton is lazily initiated, meaning we only load all the skills if we actually call for it. But generally speaking, everything we've seen will be loaded in every scene. So as you can see, this data, it really isn't that big. So I'm really not too worried about loading into runtime memory. So we look at the item database. It's a very similar looking class. I definitely could have used generics, but I do prefer the flexibility of adding relevant helper functions. Like here we have some useful functions for item generation. And the reason we keep an original dictionary and instantiate new skills when we request it is because I need to modify the values based on things like character stats and status effects. So finally, I could explain why we need that rebuild console command when we edit scriptable objects. The rebuild console command calls this function here, which gets a new skill instance for every skill in the game, and updates all the skill data based on our current character stats. And normally we just need to get the skills we have unlocked, but because it's a debug command, we use it to get every skill in the game. And since we build this database dictionary in runtime, this is why we don't need to run that command if we edit it outside of play mode. You may have also noticed earlier that status effects are not in the resource folder, and that's because I don't need to load it into a database where we can modify instances. This is because the status effects attributes are never edited in runtime. So this is just static data that loads in with any other skills that needs it. And these runtime dictionaries is what my serialization is also based on. So for example, to save the player skill bar, I just have to serialize all these string skill IDs. And when loading back the data, we take those same string IDs and then we request it from the skill dictionary. Item saving is very similar in that we only need the IDs of the affixes. But it's much more tedious because we also have to save things like where it's equipped and the location if it's in an inventory. It's serialized as this item data type, which stores an affix entry, which finally has the string ID, where we can load the proper affix using the affix dictionary, which again looks very similar to all the other databases, but there's some extra logic for the affix groups. So finally, I can talk about how the skill trees in this game are implemented. And if you want to see how these skill trees work mechanically, you can check out my separate video. So as you saw, this game lets you have 4 different skill trees. So we have to make sure they don't overlap, which is why I have this separate scene that I use to make sure they're within their bounds in each of the 4 locations. So we've seen how easily we can compose complex systems by using different scriptable objects together, but the skill tree system takes it one step further. So once again, I wanted a system where we can create skill trees with as little code as possible. And I do this by using a framework called Xnode. So this is our Brawn skill tree, which is this one here. So Xnode is just a very lightweight framework where I can easily render these nodes onto the screen for editing purposes. So these nodes are just an extension of the node framework. And this class provides all the functions we need to create and manage the skill tree system, both in edit time and runtime. So for example, the traversal algorithm that I use to check if a node is connected to a root is stored in this passive node class. And this is a very basic brute force method that was inspired by Path of Building by OpenRL. So everything in this skill tree scriptable object is actually synced directly with the prefabs in this skill tree editor scene. So if I were to create a new node here, let's say it's a passive node, we can see it actually spawned a node automatically in the scene. And if we check the prefab here, this node is already saved into the Brawn prefab. And all these node names are generated with a basic algorithm, so there's no repeating. And all of these are the connectors. So if I wanted to connect this node now, let's say with this one, we can see a new connection has been made, and we can see it update right away here. So when I created a node here, you'll notice that the position correlates with the position here, roughly. But if we move the node here, it does not update the node in the scene. And I actually had it synchronized originally as well, but I found that it's easier to not synchronize the positions just because the size of the nodes are different. And aesthetically, this flexibility helps a lot in making it look nice as well as fit into this cross pattern here. So deletion works as expected as well. If we delete this, it will now be deleted in the prefab as well. And every single one of these nodes use all the systems we've seen. So for example, if we wanted this node to give a certain passive, we just add to this array. And we can choose our stat and modifier and value, just like we saw in our items. And this is now saved into the scriptable object and will be automatically loaded when we boot up the game again. So just to show that, let's go back to our other scene. And if we go to our brawn tree here, we can see that this node now gives 2% magma damage. And if I assign that node really quick, and if we check our character stats here, it is now applied. We forgot to give our magma stat a display name, so let me just fix that really quick. So we need to reassign this. And go to stats, and now we see magma damage increase 2%, and it will work with all our skill tags as expected. And everything is serialized, so if I save now, and I close the game, reopen the game, and load our profile, we can see that the tree and all the assigned nodes are saved, and the stat applies as you'd expect at the start of the game. So I just want to show the node creation actually works. If we look at our brawn tree right now, it's what it looked like before with our magma node. So we go to our X node framework and add the node here. And we'll connect it, and I'll name it, this is a test with, say, cold resistance 10%, and you can actually get skills this way as well. So we can also add the discombobulate skill, and we'll make this look a little nicer. We do have to apply the changes manually when we move the node here, and we'll load our game back up. And we'll see our new node here. And the quest system works very similarly. I also use Xnode, and we have these task scriptable objects, which has all the data required for a completable task in this game. And as you can see, you can make some very complex quests with this system with branching paths, which is exactly how the dialogue tree system works as well. So all of these very long nodes are all the requirements needed for this dialogue option to show. And we can do all sorts of complicated things, like for example, this node will loop back to the beginning here. And the dialog node class is just a bunch of switch checks for all the different requirements. So here in town I can show the dialog and quest system in action. We have Bob and Jack here. And this UI correlates to the dialog tree we saw earlier. So there's all sorts of different tasks we can do, but this one requires us to buy a dagger. And we can get a fight here. And if we go to this menu, the relevant quest will show up. There's also a very debuggy looking quest journal right now, but this is also functional. And that's pretty much how I use scriptable objects to implement my RPG system. I didn't show every single system like armor sets and AI stat generators, but they mostly use the same ideas. So as you saw, all these systems are very modular and they integrate with each other very well. And code-free content generation is very easy to do. I chose to implement everything this way both as a challenge and also with the prospects of having team members who don't necessarily code. But this system certainly still works very well for myself, for general content generation and quick prototyping. Scriptable objects are a Unity thing, but I'm sure there are analogous systems in other engines. Because like I mentioned in the beginning, these are just instances of the classes we write. So all we're really doing is just taking advantage of object-oriented programming. So without all this fancy UI, we can certainly just instantiate manually in code, or use something like JSON to store all the object instance data, which happens to be exactly what Darkest Dungeon 1 does. So for example, their trinket data is all stored in this JSON file here. And that's all I wanted to show. You can check the other videos to see how my skill tree system works in gameplay, as well as an overview of all my shader experiments in this project. And both of those are commentated similarly to this one. Thanks for watching.